Hey, this is Leach with Simpson Math, and in this video, we are continuing to look at how to factor using the AC method. This is also part of a series of videos which will serve as a fundamental review of factoring geared towards the college algebra student. If you haven't watched my previous videos, especially the most recent one about the AC method, stop watching this and go back and check that one out. I'm going to move a little bit faster in this video, so if you're ready to go, let's get started by factoring 2x squared minus 9x plus 4. As you recall from the previous video, we have 6 steps for factoring using the AC method. They're also right above my head. So first we check to see if they're written in the right order, and they are. Then we check for the GCF and factor it out. The GCF in this case is just 1, so we're good to go there. And then we got to find AC. Well, A is 2, C is 4. Multiply them together and we get 8. So now we have to find the factor pairs of 8 that add together to give us B. So let's first write down factor pairs of 8. We get 1 and 8 and 2 and 4. And so now we have to add them together to get B, but whoa, this time our B is a negative 9. So again, hopefully if you're one of my students that you've done the products and sums worksheet, so that way you can make sure that you're good to go and familiar about finding these negative sums. So if it's going to add together to be negative 9, but when I multiply them together, I have a positive 8. Well, if I multiply a negative times a negative, I get a positive. But if I add a negative and a negative, it's still negative. So that means I'm going to use a negative 1 and a negative 8, and that will give me a negative 9. So let's do that. Again, negative 1 times negative 8 is positive 8. But negative 1 plus a negative 8 is negative 9. So I'm going to break up negative 9 into its two parts. So it's a negative 1x minus 8x. Again, you can always just do a quick double check and just add those together, and I would get that negative 9x. So now I just need to factor by grouping. So let's do the same thing we did previously. So I'm going to pull out the x, which is what the green ones have in common, and I'm left with x times 2x minus 1. Now, what about that second set? So the GCF of negative 8x and positive 4 is what? If you recall from my GCF video, you have to make sure to deal with that negative if it's first. Since our leading negative is negative, since our leading coefficient is negative, then our GCF is also going to be negative. So the GCF of a negative 8x and 4 is negative 4. So basically, like you heard me say in the last video, whatever the sign is here, whatever that operation, whether it's adding or subtracting, make sure you have it written in the second row. When it's a plus, it's just to make sure that this line equals this line equals this line. We're writing expressions that equal each other, not just making notes to ourselves. Here, if you don't write the negative, that's a big problem because we're going to use that sign to make sure that it's going to be an x minus 4 in our next step. All right, so 2x minus 1, we have a 2x minus 1 in both. So I'm going to pull out that as a bigger GCF, 2x minus 1, and left hand side is an x minus 4. So there we have it. We just factored 2x squared minus 9x plus 4. Only difference this time really is that we have these negatives to deal with. All right, this time, let's find the roots of f of x equals 3x squared minus 19x plus 20. If you want to go for it, pause it, try it on your own, be my guest. But I'm going to still go through this one with you because I really want to talk about this next part. So GCF is 1, that's cool. AC is 60, that we should be good with that, 3 times 20. But I want to talk about here, about our terms. Now, you are welcome to write down all of those, and until you become a factoring pro, I want you to write down all of them. But there's gonna come a point, especially when these numbers are bigger, and if you practiced a lot, and if you've looked at your homework, and there's a lot of practice there, that you're not gonna be wanting to write them all down. So let me show you an added benefit. So yes, we're gonna end up with this factor pair, negative 4, negative 15, which adds to negative 19. I already have that written down. But I wanted to just show you a little bit of convince you again about why I want you to write them in this order, starting at 1 and then increasing. So the first one was, it helps you make sure that you got them all. So 60 does have 1, 2, 3, 4, 5, 6. All the first 6 numbers are a factor of 60. So you can check 7. Nope, that's 56 and 63. Nope, 8. Again, if I'm skip counting, that's where I said with the 7. So 7, nope, 8, nope, 9, nope, 10 does with the 6. But once you get that 10 on the other side, I don't need to check any of the others. So I just checked the first 10 numbers, and I did not have to check the last 50. So that's reason 1. Write them in this order. Reason 2 is that it helps you for them to then find your values. So let's say that you didn't want to write it, and you're like, okay, well, I know 3 times 20 is 60 because I just did it, right? This right here is 3 times 20, so let me just start with that. That might work. So, well, what if this was a negative 3 and a negative 20? That would equal a negative 23. Okay, let me just keep adding these up. So now, I want to make a point. So what if it was a negative 2, negative 30? This would be a negative 32. This would be a negative 61. So I want you to notice about these numbers. So as I go down this list, oops, I left my negative off. These numbers are getting smaller if you're ignoring the negatives, or closer to 0. And so they're going to be following in that pattern. If you ignore the negatives, basically funneling down and getting smaller. So whenever I just tried, well, I was like, well, I don't know. 3 and 20, that equals negative 23. I don't need to try any numbers above, because I know the number I'm looking for is a negative 19. So I know that it is somewhere below. Now let's just say I forget about 4 and 15, and I jump down to 5 and 12. Well, a negative 5 and negative 12 add together to be negative 17. Or say I started there. Well, negative 17, that is smaller than my negative 19. Well, further away, it's closer to 0. So that means that I'm able to then go up this list, because I know that it should then be, its value should be further away from 0. I can then go up. Right? So there's, again, that kind of a funneling idea of those values are getting smaller if they're positive, or closer to 0 just in general. So that should help you to fine tune without having to write down the full list, as long as if you were to write them down in that order. All right, so there's enough rambling about that. So our factor pair is negative 4 and negative 15. Again, they're both negatives, because if I multiply, they give me a positive 60. But I add them and I get negative 19. So then let's quickly finish this up. And I have my negative 19x that I broke apart into negative 4x and negative 15x. GCF the first two, just an x. GCF the second two, we got a negative 5. Now, again, just a reminder that I'm always writing the number that is closest to 0. It's in the same order as what we saw over here on our factor pairs. I'm always going to do it that way for consistency, but if you did switch them, you would end up with a different pairs inside, and what's on the outside would be swapped, but then when you're done, you're going to end up with the same 2 binomials. They just might be swapped. And then one other just point while I'm talking about picky things, I want these the 0 equals all the way down, because we're finding the roots. If we're not, then I do want the equals on every single step. I'd put a gray box around this one, just sort of kind of like it's like a halfway answer. It's like, oh, I factored. I'm done with that factoring part. For my students, I've asked you to, on a similar problem, to draw a box around your factors, the factored form, and that's what I'm talking about is right there. Well, let's finish this up and find the roots. So to do that, I'm going to set each of these equal to 0. So set each equal to 0. So I do this, and I add 4, divide by 3, and I get x is 4/3. And then I can just add the 5 and get x is 5. Write them in set notation. So my answer is x is the set of 4/3 and 5. The reason why I'm putting in that set notation is they're both answers, they're both a part of it, so it's a set of these two numbers. All right, one more to check out. All right, if you're like, oh, it's the last one, whatever, this one is different. So this is going to be the first time that you're going to see something different. So make sure that you watch this one if you're getting bored with me. All right, so step 1, simplify and write in descending order, done. Step 2, factor out the GCF. Up until this point, it's just been 1. But look at this, 2x squared minus 24x plus 70. All three of those are even numbers. Since all three of those are even numbers, the GCF is not just a 1, it's at least 2, and it is 2. So that means I need to go through this process a little bit carefully, a little bit more careful. I'm just going to go ahead and unveil it all and just walk through it. So so what I have to do is actually pull out the GCF. So I noted that the GCF is 2, but it's not noticed. This step right here, I can't get there, but I can get to it if I do this. Yeah, there we go. So this step right there, it says factor out the GCF, including the -1, not just make a note about it. So it's 2, whoop, there you go, it's 2, but I got to make sure to factor it out. So let me do that first. So I'm going to factor out the 2 of the GCF, and then left inside is then x squared minus 12x plus 35. Again, you could do a quick mental distribution to double check, but there we have it. I'm using square brackets instead of parentheses, nice tall skinny square brackets, because I'm going to be using parentheses when I do my factoring, and just double parentheses sometimes gets a little bit crowded, and it's just a little bit more visual separations. If you want to use parentheses, be my guest. In terms of algebraic expressions like this, parentheses and square brackets achieve the same thing. They do the same thing. All right, so at this point, once you have your GCF pulled out, then this 2 is in a way dead to me. Or you can think of it like this, like a little lost puppy. So if you're ever out and about wandering around and you see this little stray dog, and you're anything like me, dogs love me, I can't help it. So this poor little dog is just going to follow me home, right? But I've been taught, just ignore it, ignore the dog, because if you whatever, give it food or whatever, then it's going to give it attention, it's really going to follow you. But just, poor thing though, you got to ignore it, and it's just going to follow you home, okay? So just let the 2 follow you. Don't worry about it. I'm not going to think about it. It can almost, in a way, just be dead to me, okay? Because at this point, I'm just going to be working with it. But you can't forget about it. It's still there. Don't want to step on it, whatever, because it will then be a part of our final answer. But at this point, it is not impacting any decisions from this point on. So now, let's continue with our process of the factoring using the AC method. So now, what is AC? Now, I'm looking at AC at my factored after I pulled out the GCF of 2. So my A is 1. My C is 35. It is not, what's that, 140. No, 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 no. The A is the value that is the coefficient in front of my x squared. This 2 is not in front of my x squared. It is in front of the entire trinomial. So this is the A, which is just a 1. So that's a really big note here. The A is not the GCF. So be careful about that. So it's 1 times 35, and then my factor pairs are 35 are 1 and 35, 5 and 7. Needs to add to be -12. What's a -5 and a -7? And we get -12. So then we add them. I then write our -12 here, break it apart into -5x and -7x. GCF it. We get x, and then we get a -7 for our GCFs. Again, whatever this sign is, bring it down. And we have x minus 5 in both, and we're good to go. One note about what happened to the square brackets. Well, notice right here, so I have this, and then I might be tempted to try to write this step like that. It might be keeping those square brackets or keeping your set of parentheses. They're not needed at this point. This is 2 times this. So just imagine if I said 2 times 3 times 5. That's just 2 times 3 times 5. Okay? There's there's a difference between it being all multiplication and this. 2 times 3 plus 5. With a plus, you can't say 2 times 3 plus 5. That is a very big difference. Because it's all multiplication, I can just drop those brackets or parentheses. So our final answer is 2 times x minus 5 times x minus 7. All right, so this video, what was really new, we saw two things new. We had this first sign was a subtraction, but this one stayed a plus. And then in this last example, you saw a GCF that was not 1. So meet me in the next video when I'll tweak a few more things. I'll see you in the next video.